Alright, let's continue. Welcome back everybody. We were building a ESP powered remote control car with ESP-RS Rust implementation. And in the last episode we successfully sent a message, a blob of bytes from the controller to the car. So that's a good start. But let's make it a little bit nicer. So sending manually some bytes over the wire, that's probably not what you really want. And I think this is where Rust as a language and as an ecosystem really shines. So we had the two sub, the car and the controller sub projects, and we're going to add another one, and I'm going to call it like protocol, something like that, because that will be shared between the two. That's like the language definition of the controller and the car, and it's kind of nice to share it because you know that you're talking about the same thing. It's a library, so not an actual executable. So now we'll have here a protocol as well. It has some boilerplate we don't need. We do want to have a no standard because otherwise it will not integrate at all. And also we need to have a external grade alloc because we want to still use the allocator. Yeah, like that, I suppose. So what we're gonna define here is basically what do we want to send from the controller to the car. And usually one way to do that is using enum. Let's pub enum, and we call it I don't know, control message. And right now let's create a variant that we steering position that takes I32, for example. So this is at this point the only thing we could say, but we could say like engine speed with I don't know, lights on, lights off, who knows, right? So you can easily add things here, and yeah, this is that works really nicely in Rust. But we'll need to send this over the wire, right? So we need to do some work to make that actually work. So what do we need to do? We're in the protocol now, and we're gonna add the serialization, deserialization, so 30, cargo add 30, no default, I always forgot features, is this the one? Yeah. And we do want to the alloc, I suppose, and the derive. I guess. Okay, so now we can add some annotations. Derive, we will say deserialize and serialize. So we can, we know we can do that. Let's, for good measure, add debug as well, and clone and copy as well. That makes it a little bit easier to work with, and given that it is probably a pretty small data structure, so right now it is basically one sort of pointer to see what variant we're having, which is only one right now, and then one single I32. So even if we add much more variants, it's only one at the time. So it's not really a big deal to make it clone and copy, and it makes life easier. So like this. So what we now need to do is actually create an implementation of it. So serialization doesn't do anything. You'll need to figure out a way to encode it and decode it. So for that there is a nice crate, and that's called Postcard. And that's yeah, a no standard focus serializer and deserializer. So that sounds pretty perfect. Yeah, you don't really need to do a lot of things. I have no idea what the actual byte format looks like, but it is yeah, it's a nice usage. And yeah, it's pretty straightforward. Let's see. Yeah, you can do alloc vec, so then you create a new vector for serializing, and for deserializing you use from bytes. So let's see if we can get this to work. I'll just create an input block for the control message and add some methods here. I start with 2 bytes, and it will take itself. And then what I'm gonna do, I think vec u8. Need to import that one. So I guess did I add? I didn't add Postcard yet. Cargo add Postcard. Do I need anything else here? I think I need definitely the alloc and maybe also the Postcard derive. So alrighty. So let's see if we have Postcard here now. Oh, it's still indexing. Indeed we have. And then yeah, we can do this. So we can take self here and we can unwrap. And then it will return that vector. I mean, ideally we should propagate the result, because yeah, maybe there is a certain way you want to deal with malformed if this somehow fails, but we will get to that at some point. And the other one, to deserialize it, that will be a function from slice. We don't get self here, but we get a pointer, some data, and then slice of u8, and we return self. Postcard from bytes, data, and we unwrap, and that's it. I need to be public. Okay, so that's this part. So what are we gonna do with this. Because we don't have any actuators in the car yet, we don't have any controls on the controller yet. So let's fake it a little bit. Let's call this send steering command. And that's gonna, let's say, send sort of random steering command. So let's say for I in minus 100. I don't know exactly yet what makes sense, but let's just start here, and we also need to create we don't really need to. So let's create a control message here. Let C is control message. We also should add the dependency to protocol, right? So we go into the controller now, and let's see how that exactly works. Better here. And then we need to point to protocol equals, and then I think, let's see. I think I did that wrong. Let's see. Something depends on itself. Oh, did I put it in the wrong one? Yeah. Okay, I put it in. Yeah, that makes no sense. I'll move it to the controller here, and that should calm it down. Let's see. Control. Control message is here now. And we say steering position I. So now it will just create a steering position message from 0 to 10 and then keep on looping. And then let's see. Then we can basically write the code to actually send it down the line. So we still need to do something here. And that goes something like this. So we'll have our we move this in here. And basically what we can do is, instead of say hello rusty car, we can, let's give the proper name, message to bytes. Is that wrong? And then like this. So now it will keep on sending steering command 0 to 10, 0 to 9 down the line to the car. Let's have a look at the car side. So we also need to add the dependency. Let me just copy that. Okay, so we have a message and we have the data. So that would be something like control message. from slice message.data and now get data. Control message, and we can let's print it. And because we implement debug, we can just do this, and it will show it in a reasonable way. And I think that should be it. Let's have a look. So this is the controller. Let's do ESP flash package. This is a controller. Okay. And we should be able to do the other one. This was the control, it doesn't matter. And the car, and we put that to the other one. And then what happened here? This is probably some dependency issue. Weird. So that one seemed to have worked, but this one has not. It's a linking error. Maybe I forgot to add release here. This one, I think. So this one seemed to be patiently waiting now. Let's see if that helps. I am honestly not sure exactly what's wrong here, because this was the controller. I am thinking it's the, yeah, it's some kind of dependency. Or maybe like this. I was in the controller subdirectory, so maybe that makes a difference. Not sure. And if not, I'll need to figure that out offline. Now it worked. Okay, so I was in a subdirectory, and probably it had to do with the cargo config, I suppose. Although I think they're identical. Can't really explain this one, but now it seems to work. And let's see. Now this one is getting the steering positions. Oh yeah, it does like 10 in a row without pausing, and then it will wait for a second. But yeah, that was pretty much what we were looking for. So yeah, I think this is a really nice model because, yeah, you can add whatever you want here, as long as it serializes in 255 bytes, but you can do a lot. And yeah, it is a very expandable thing. And later in the next one I will, or maybe not in the next one, I'm not sure yet. I'll need to look at the servos and have some actual inputs to make it a bit more realistic. But yeah, this is very nice way to work. You can add whatever you want, and if there is a problem, you'll have one code base, so it's kind of mono repo. So again, if you liked it, please leave a like. If you have ideas, leave a comment, and see you in the next one.